Welcome to this explainer. Today, we're unpacking the real financial and environmental realities of renewable energy storage using the SASB standards as our guide. Now, if you follow the clean energy space at all, you already know how absolutely crucial utility-scale batteries are, but today, we're looking at what happens at the end of the line.
It's a pretty fascinating question, isn't it? Where exactly do utility-scale batteries go when they die? Picture a massive, depleted industrial battery. Its journey actually doesn't end just because it stops holding a charge. In fact, rather than reaching a dead end, a complex, completely new life cycle kicks off. And honestly, how a company manages that specific life cycle can make or break its long-term financial health.
Let's dive right into Section 1, the utility-scale battery afterlife, focusing on hazards, laws, and liabilities. To really wrap our heads around the aftermarket of these energy giants, we first have to look at the hazardous reality of the materials inside them. Notice how strict the definition of hazardous secondary materials is. It includes any spent material displaying ignitability, corrosivity, reactivity, or toxicity when discarded. Under global frameworks like the UN Basel Convention, these are heavily regulated, and for good reason. They pose a direct threat to human health and the environment if they aren't handled correctly.
We are dealing with a seriously potent mix of substances here. Just think about the components commonly found in these industrial batteries: solvents, corrosives, lead, arsenic, cadmium, sulfuric acid. The workforce handling these, not to mention the surrounding environment, face severe risks. So for manufacturers, disposal is absolutely not just some operational afterthought. It is a critical risk vector.
And because of these risks, global laws on battery disposal are rapidly emerging everywhere. This turns improper hazardous waste management into a massive legal and financial liability for companies. With stricter environmental regulations on the rise, simply throwing away a utility-scale battery? Yeah, that's no longer a viable or legally defensible option. Companies doing that can face severe litigation and crippling fines.
Moving on to Section 2, the critical materials squeeze, where we'll look at scarcity and supply chains.
You see, the problem isn't just about avoiding toxic waste, it's also about the incredibly valuable raw materials we might literally be throwing away. These elements are the building blocks of the green transition. We're talking lithium, cobalt, nickel, platinum group metals, and rare earth elements. We absolutely need them to build the future, but there's a finite amount that's actually easily accessible. And the supply risks here are immense. We are talking about physical mining limits, wild price volatility, and a heavy reliance on regions with limited governance or rising geopolitical tensions. Compounding all of this is the intense competition. Every other tech and energy sector out there is scrambling for these exact same scarce resources at the exact same time.
Which brings us to Section 3, the circular economy solution, also known as the take-back loop.
So how do companies survive this massive supply squeeze? Well, this is where a sort of financial alchemy takes place. Smart companies are transforming regulatory threats and supply chain squeezes into a highly profitable, self-sustaining loop. The logistics of this take-back loop follow three main steps. First up is disassembly, which involves direct product take-back programs and collection right at the end of the product's useful life. Second is material recovery, where companies safely reclaim both those valuable critical materials and the dangerous hazardous ones. And third is reuse, literally incorporating those recovered elements directly into new manufacturing. By setting up direct contracts with specialized reclamation services, companies safely recover materials and completely change their financial risk profile.
And here is why this is such a game changer. Developing these take-back programs and recycling systems turns resource scarcity into long-term operational efficiency. It's an elegantly brilliant strategy, honestly. You secure a steady supply of critical materials directly from your own depleted products, completely bypassing the chaos of the global supply chain, all while avoiding massive disposal fines.
Let's look at Section 4, measuring the take-back loop using the SASB scorecard.
Okay, so all of that sounds great in theory. But how do investors know which companies are genuinely mastering the circular economy versus those who are just, greenwashing? Well, they look to the SAPS standards, which are now part of the IFRS Foundation. These standards provide very specific, rigorous metrics to evaluate a company's product end-of-life management. It essentially forces transparency right onto the balance sheet.
The standards act as a really strict scorecard. Just take a look at the specific units of measure they require. Metric 410B.1 asks for the percentage of products sold that are recyclable or reusable, specifically measured by weight. Then, metric 410B.2 requires the actual metric tons of end-of-life material recovered along with the percentage recycled. This forces companies to quantify exactly how much end-of-life material they are successfully keeping out of landfills and incinerators. I mean, you can't fake metric tons.
Now here's a really fascinating detail: the 60% threshold. The SASB standards don't just let a company slap a recyclable sticker on a giant battery and call it a day. A product can only be claimed as universally recyclable if recycling facilities are actually available to at least 60% of consumers or communities where the item is sold. If it's less than that 60% mark, the company has to add qualifications. They simply cannot make a blanket claim.
The standards also demand incredible precision about what actually happens to the parts. There is a very strict distinction made between reused and recycled. Reused materials strictly means that recovered products or components are being used for the exact same purpose they were originally conceived for. Recycled or remanufactured, on the other hand, means waste was actively reprocessed or treated through manufacturing into a completely new component. The standard doesn't let companies blur those lines.
Furthermore, you can't just hand off highly toxic electronic waste to any random scrapyard and claim you recycled it. Not a chance. According to the standard, companies must prove they use third-party certified recyclers, specifically noting rigorous certifications like E-Stewards or the R2 standard. This is crucial because it prevents the downstream pollution that happens when e-waste is quietly shipped off to regions with lax environmental oversight. That accountability, it tracks all the way to the end of the line.
So what's the crucial takeaway from all this data? It's pretty clear. Mastering this loop effectively mitigates financial risks from volatile prices and safely secures critical materials for the future. Ultimately, companies that intentionally design their batteries for disassembly right from the start and actively implement true, certified product take-back systems are fiercely protecting their shareholder value in a resource-constrained world.
Which leaves us with this final thought to ponder today. As the energy transition accelerates, and literally millions of tons of industrial batteries are deployed globally, we have to ask ourselves, are the creators of these massive energy giants actually taking responsibility for their aftermarket, or are they simply delaying an inevitable environmental and financial crisis? As always, the data will be what tells the real story. Thanks so much for joining me on this explainer, and keep asking those tough questions.